So this will be like a folder, maybe a zip file will be uploaded, as well as this folder will be uploaded on the Blackboard. Inside the folder, you will find two subfolders and one HTML file, one notebook, Jupyter notebook file, and one PDF file. If we are using any data in our chapter, in that particular chapter, that will be available in this folder. Okay, that will be available in this folder. For this chapter, we are not using anything, but in general, this is just dummy. In general, if you have any data used in the Jupyter notebooks, it will be in this folder. If you have any videos or any images or anything used in the notebooks, that will be in this folder, images, IMG. So every slide, every topic actually will have a zip folder as well as a folder on the Blackboard. You can download the zip file and unzip it on your system, and you should be able to find two folders. The checkpoint folders is automated. It's generated whenever you save and modify the Jupyter notebook. So that's something not you can delete it or keep it. That's fine. But you should have two folders and three files. The first one is a notebook file, and you can open it through your Anaconda package and Jupyter notebooks. And here is that notebook file. Okay, and then we also provide you with HTML and PDF. The HTML one and PDF one are something for you to refer. Let us say you want to get a quick reading, and you don't have Jupyter or even uh, Anaconda Python installed on your system. Let us say you want to read things from your phone. Then most probably you will open the PDF file. Okay, like here in the PDF file. That is exactly what we have in the Jupyter notebook, but of course without the codes and maybe without the graphics. Or you can open the HTML file, and that HTML file will contain everything. So you can open the HTML file on your mobile phone or in even your tablets. You don't have to have a Python installed. Of course, you cannot read the code, but at least you can read and see what is happening in there. Okay, you can execute the videos, and that's something nice. But the coding part is still not available. Okay, and if you want the coding, then you must have to have Python. You can also save this file and open it through your Google Colab. So if you want to execute things on the go, then you can, Google Colab is an online way of programming in Python. So you can go to Google Colab and then open the notebook in Google Colab. And then even through your phone, you can work on the notebook. So that's why we have these three files apart from the two folders. In the class, I will be just opening the notebook and we'll be going over the contents in the notebook. But we have other ways of learning as well. All right. So now let us start. This is the first topic, introduction to data science. These are all the topics, and we are in the first topic now. That's the outline of the course. And these are the contents. We will see all these contents as we proceed. Every chapter will have a similar, every slide will have a similar style, and in the end, all the references will be given. Okay. Let us start with the data science. We are trying to see something about data science. Okay. Now, we are not going to learn data science in this topic for sure. In the first topic, we are not going to learn data science, but we'd like to know something about data science that will make the course interesting. Okay, that will make this topic valuable. Okay, just a second. All right. Yeah. Now, these days, every one of you here or sooner or later you will know how to use MS Word, how to use Microsoft Excel, and maybe how to use PowerPoints. Most of you, even you are in freshman, I believe, or above, and most of you know this, right? Is there anyone who don't know Microsoft Word or PowerPoint or Excel, MS Excel? Have never used it? Or how many of you have used this Microsoft Office tools?
I think most of us have
Yeah,
used
most of us did.
Yeah. Okay. Yes. Now these things, maybe 15 years back or 20 years back, were not this common. People used to take this as something beyond the common knowledge. Okay. So why I'm saying this, because data science soon will be the thing that will be common after maybe 4 or 5 years. It will be a common knowledge that every graduate should have. That's it. Whether you are an engineer, whether you are from business, whether you are from even medicine, even the guys who are in medicine, they are now learning statistics and data science. So this will become a common knowledge, something that every graduate should have. If somebody say you are a graduate, either from business, from engineering, from medicine, they will expect that you should know these things. Okay, so it will be like nowadays, my Word, Excel, and PowerPoint. Data science will be similar. But the moment you graduate from KFUPM, you will see that every job requirement will have this as a default skill. And that's why in KFUPM we have these three courses, digital enablers. Okay, so most of you, you might have a thinking that I am from this background and that background, and where would I need it? No, it's not the right thinking. Think about 4 or 5 years, and you can Google now. Even just Google data scientist jobs, and you'll find so many companies that are looking for data scientists. In fact, people say that there are more jobs than the people in this field, and that's the way every field will begin, and over the time it will saturate. So once you graduate, you will find this something very important, and you can add it as a part of your CV. And the other thing is, this field is so you can say common that you find lots of competitions going on with good amount of prizes. For example, here there is this website called Kaggle. Okay, this is one of the famous websites for the data science, and here you can see competitions, and then it lists all the competition. These competitions are across the world, and different companies, maybe sometimes government companies, and mostly the private companies, they have some data that needs some analysis, that needs some look from data scientists. So what they do is they upload the data on the website, and they say what they are looking for, what are they trying to find from this data, and then they give a cash prize. For example, here is a data that actually released 2 months ago, and then you can click and see what are all the details of the data, but maybe it's too early to see. But then these guys will give you some cash amount, and sometimes the cash amounts are quite large. This is open for everyone. A faculty member can be competing here, a student can be competing here. You can have a friend from one country, other country. You can make your own team, register your team, and then you start working on the projects. There are so many projects. Sometimes things are easy. The prices are the worth or the price value are small, and then sometimes it's challenging, and the price is quite high. Okay, the price value, the amount is quite high. And then there are some just for learning, you have this without any money. So you can see that these things are the knowledge that you have here in this course will be helpful for you and will be beneficial for you. Here's another website that gives you different things that is happening in the data science world. It's called as KD Nuggets, and it's asking for email and everything. But here you have so many tutorials, top stories, many things, many things happening. So you can see that this area will be quite helpful for you. Once you are done with the course, you can make a team with your friends, and you can participate in those competitions in KD Nuggets and Kaggle. And who knows, maybe after a couple of years, you might be getting some prize in one of the competitions, and that amount could be quite high. And one of the other good thing about these websites is when you show that what you can do, people will come to you for consultation, and that will be another sidekick from these websites. So it's a good area, data science, and if you guys are interested, you can also think about data science consultation later on. But at this point, remember one thing: data science has two parts. One is the knowledge of data science, the other one is how to apply. So never mix these two things. How to apply depends on the tool. For example, in our course, we are using Python. You have many more tools available out there. You have NIME, you have R, you have Rapid Miner. You have so many. I'm just saying few. Vika, Java. From Java, you have Vika, but you have so many, and it's open. But in our course, we are using Python. So never mix or never assume that Python is the only way of data science. No, but it is one of the good ways, one of the, you can say, professional ways. For example, let me click on any of this one, and you go to the discussion, and let us pick the best one, maybe. Yeah, this one. And this guy must be doing something. Okay, maybe here, let us see. Yeah. So here, let me look at this. Yeah. So he is using Python. You see, he's giving the code. He's using Python to analyze the data. Okay. So they're helping the teams with their ideas to what to analyze and how to analyze the data. Okay, so the code is available. So you see, Python is a standard way of doing data science projects. And if you find difficulty in Python, maybe because in ICS 104 you didn't had enough practice, or things were not clear, then at least in the first week, let us try to get rid of those issues so that it becomes easy. Python is very straightforward. I think this is the simplest programming language so far. Okay, that's why it is so popular. Okay. So here we are going to learn something about data science, where and when about data science. Okay. Now let me zoom it here. Okay. Now we are going to learn three things in this topic so far, or we'll be looking at these three things in this topic. We are going to identify where data scientists typically fits in a business project. So if you visit, let's say, a company, you will have, or if you visit any university, you have so many departments, right? Similarly, I'm not sure if you visited any company, but let us say if you visit a company, you will find that there are different domains, there are different departments, you can say, in a company. You have a production department, you have a marketing department, you have sales department, maybe marketing and sales together, maybe you have a finance department. So you have different departments, okay, different work domains. So we're going to see the first thing, where as a data scientist usually you fit. Okay, where is a data scientist place in the business world? And then we're going to see how data-driven based decision making is different from the old style decision making. Decision making, you have to make a decision. For example, you have to make a decision to take which class. So you made a decision. How you made a decision, that will be different. Okay, most of you took a particular major. Most of you have a major now. Some of you could be from business, some of you could be engineering, some of you could be, inside the engineering could be mechanical, petroleum, civil, industrial, whatnot. So you must have taken a decision, and everybody takes a decision. Every day you make lots of decisions. How you make decision based on what? There are different ways, and one of the ways is data driven decision made based on the data, and that's what we're going to learn, just something very small quickly in this topic. And then we are going to see what are the basic processes that you have in a typical data science project. What are the different steps, or you can say the cycle of the data science projects. Hopefully, by the end of this chapter, you should be able to know your role. Let us say if you are going to be a data scientist, your role in the company, in the workplace. Okay, and then you should be able to tell how important is the data-driven approach for decision making, and you should be able to tell what are all the steps or phases of data analytic life cycle. Let us start with the first topic, the role of data scientist. Where do you fit in? Given a company, where do you fit in? For that, here I have a simple picture. It's taken from this book number 2, which is in the references. You'll see, you can see it later. And this book gives you like a, you can say, concise picture of different individuals that you find in a typical company and where data scientist fits in. So you have these 7 roles, typical roles that you find in any decent firm, not necessarily international firm, even the national firm, the local country level firm will have these 7 roles. You have a business user. That's the guy, you can say, who knows what business to do. He is the guy who is giving you he's bringing the business to you. He's the guy who, for example, let's say you have lots of money. Let's say you have lots of money and you would like to invest, okay, or you would like to start a company. What to start, which area to go, all these things. Who knows it? It's a business user. He knows that what product can be sold and where it can be sold, and how to make it or who can make it, and all these ideas. So he has the knowledge of the business that is being done. Okay, he's the guy who has the knowledge of the business. He's a business user, or he's the guy who is into the business. Okay, and he's the guy who, and all of these are written here. Okay, so that's the business user. Okay, he is the guy who's getting the benefits from the business. Then you have a sponsor. Who is this sponsor? He's the guy who is actually funding the business. Okay, the business user may not be the guy who has the money, but he might approach different entities. Typically, banks are the entities, and you can also find individuals, and you can find companies who are helping in sponsoring, and those are the project sponsors. You could have one sponsor or many sponsors. Okay, that's the project sponsors. They are the guys who are typically funding the business. Okay. Then you have the project manager. Who is this guy? This guy is trying to make sure that things are done on time. He's the guy who's going to break down the entire project into different tasks. And then he's going to set the deadlines, the milestones. He's the guy who's managing the project, and that's the name, manager. He's trying to make sure that everything is done on time, and he's trying to make sure that the results are delivered on time, so that the business user gets benefit from that. Okay. Then you have the business intelligence analyst, BI in short, analyst. Okay. What this guy is going to do, going to give you some ways to see how good you are doing. So if you have a project with so many steps, then the BI analyst is giving you some hints on how you are, you can say, following those steps. Are you doing good or not? How do you measure it? By KPIs, key performance indicators, KPIs. So business analyst is the guy who's going to give you the KPIs, who's going to give you the results of KPIs. He's going to provide you with all the data and the results and try to tell you how you perform the different indicators. And this will help the manager, if needed, to do some shuffle, some changes to make sure that everything is moving in the right direction, in the right track, in the right steps. Then if you look at in terms of data, you have these guys. You have a database admin. This guy has all the data. Okay, he's the guy who's maintaining the data actually. A database is the place where the data resides, and database admin is the administrator. He is the guy who is controlling this database. He is going to decide everything about the database. Now, data engineer is the guy who is going to extract the data or update the data. He's the guy who's maintaining the database. Okay, he's the guy who is maintaining the database. He's coming up with different extraction of the database, and then those extracted data from the database is given to data scientist for the analysis. Okay, and data scientist takes the data and he does all the analysis based on what is required, based on the objective, based on the request from the business user. He is going to uh, do the analysis and he is going to give the results. So these are all the 7, you can say, typical roles that you have in a company that has to do something with the data science. Okay, of course you might have a company which doesn't have these 7 because they may not have data science related focus, data science related goal. But if you have a company with that data science related goal, yes, you will have these 7 roles. Now, sometimes because the companies, maybe because the manager or because somewhere here, people don't have a clear differentiation between data engineer and data scientist. And that's why these roles are sometimes mixed. Sometimes data scientist has a role mixed with the data engineer and vice versa. But strictly speaking, they are different. The purpose of data engineer is mostly to maintain and extract the data from the database, whereas data scientists who actually analyze and interpret the data. And these two are different things. But for somebody who's not into the data, who's not who doesn't know what data is and how the data is being handled, he might take these two as the same, one and same, but it's not. Okay, and the details of these are here. Now, this chapter is not part of any exam or any homework or quiz or anything. It's just like an overview. So if you want to read, yes, go ahead and read from here or from these references, but it will not be asked in the homeworks, exams, or quizzes. Okay. So those are the 7 roles that you typically find in a company that has to, in a workplace that has to do with the data. To summarize, like a recap, data scientist, what he does, he provides subject matter expertise for analytical techniques and data modeling. So given the data, he tells you what are the techniques that fits your objective for this particular data and how we can model the data. Okay, and then he's going to apply valid analytical techniques. So you might have so many techniques, and not all of them may be valid for this. So you have to be very careful, and data scientist knows which one is valid, which one is not. Okay, and ensure that overall the analytics objectives are met. So what are these analytics objectives? Well, somebody must have told you when the data was given, maybe the data engineer or the project manager or somebody at the higher level must have told you that this is what you are looking for, this is what you need to do, this is what you're supposed to get from the data. And then you make sure that when you're analyzing the data, you are trying to fulfill those objectives. Okay, and finally, the data scientist, he is going to design and he's going to execute all the methods and approaches that he have, those valid approaches, and then he's going to present the results to those guys. For example, he might present the results to the database admin or the project manager or anybody, depending on the requirement. Okay. So that's the role of data scientists. Now, what is a data-driven approach? The data-driven approach is basically telling you when you have to make a decision, don't go with the intuition, but go with the data. You must have taken so many decisions. Okay, for example, if I ask you, why did you pick a particular major? Can you answer that? If I ask you, why did you pick your major? Can you tell me? Can you write that I picked, let's say, petroleum engineering because, can you fill this gap? Anybody in the class?
I can say that I picked a major because that's the data set that the market needed that specific major.
Okay, so this is one answer. Any other answers? You can write it in the chat box if you don't want to talk, but
Because
communicate.
maybe I like this major.
Okay,
Maybe there's a high job
but like,
market major.
okay, because you have job market. Okay. Any other reasons? Anybody here who says because my brother is in the same major or my family member is in the same major? Yes? No? Well, don't be shy. You don't have to be shy. So there could be different reasons. And based on different reasons, you have landed in a particular major. Okay? That is fine. But the reasons could be broken down into two. For example, somebody said, because I like the major. So it's his intuition that he likes the major. If it is backed up by some data, then it's data driven. Otherwise, it's just intuition. Intuition, like, my brother was in this major, so I will go with it. Or my uncle or somebody was in this major, so I'm going it, and various reasons. Okay, so that's intuition based. But some other answers that I was getting from you guys is related to data. For example, you're saying like because of the job market. Maybe you googled what are the job market for different engineering or business majors, and you must have found maybe this particular or that particular, and based on your you can say a view of what job or which company you are planning to land, or for higher education you pick that major. So you have some data, you did some past history, you looked at some data, how things are changing or happening in the world, and you picked the major. So you could have intuition based or data driven based. That's the data driven approach. Now, for such simple decision, of course, it's not a simple decision. It will have, the major that selected will have an effect for next 4 years or beyond in your life, no doubt. But there are decisions that might have much more effect for tens or beyond, and could be huge in the amount of risk involved, and in huge in the amount of effect that it can have on one's life. Okay, and those decisions, again, you have to make decisions, and you can make either using intuition or data, and that's where the data driven approach pops up. Data driven approach says that if you go with intuition, there could be blind spots, because intuition might not cover everything. Intuition might not cover everything, and you could have some blind spots. And in business world, that blind spot could be nothing. You could just ignore it, or could have a huge effect on your business. So you don't want to take that risk of having a huge effect on your business. So you have to be careful, and that's why you are suggested, or that's why you have this data driven approach. Basically, the simple idea will be like, let us say you are now, you like to go out from home and to some, let's say, park, some playground or park or something. And the decision that you have to make is, do you have to carry umbrella or not? So what data do you think you will be looking at, okay, to make this decision? Should you carry umbrella or not? Everybody knows what umbrella is, right?
Yes.
Yes.
Okay. What do you say? How do you say umbrella in Arabic?
مظلة.
مظلة.
Okay. So tell me, what will you look at before deciding should you take umbrella or not? Of course, let us assume it's not raining right now. If it's raining right now, then for sure you will carry some protective gear, umbrella, for instance. But let us say it's not raining right now.
What is the percentage?
The
It may
weather
rain
forecast.
in the few next hours.
Yeah. Now these days, has mobile phones, so this was the expected answer. But imagine the days where there was no mobile phones. People would look at the sky, they would look at the
Yes.
previous day or early in the morning, how the weather was, right?
Yes.
Yes.
Yeah. So something history. People are trying to look at the data in the past, trying to see the data from the past, and from that you're trying to conclude based on various factors. Of course, this is something rough, but that is nothing but data-driven approach. decisions will not be so simple, and decisions could be more complex. So your analysis would be also further complex. This umbrella example is a simple decision, simple analysis. When you have a complex decision, for example, let's say you are a CEO of a company, and you suddenly realized there is a huge inventory in your warehouses. You know what is inventory? Inventory is like the stock, the raw material or the finished item inside the warehouse. It is not sold to the customer. So that will be a huge cost because it's the money that is lying in that material. If it is not sold on the right time to the customer, then it will depreciate. So having too much inventory is a big issue. If you see the companies nearby, you'll find that most of the companies, at least in this eastern region, you'll find those companies are facing this issue a lot. They have lots of inventory and they don't know how to deal with it. So now what decision to make? Well, it's not a simple decision like taking umbrella or not. So you need some big analysis, some good data analysis to see why the inventory is being developed, what is the issue, where is the issue, how to rectify it. So then you need data-driven approach. Of course, you could go with intuition. Most of the time, the old, no, not old, it's a traditional style. Before the statistical approach, data-driven approach, it was all intuitions. You look at the past, even in some management disciplines, not all, but in some management, you have this past case studies where they just talk about how things happened in the past, and using that, people try to see if it can replicate in the future without any data. Okay, but in our case, in at least from this course, we are going to see that data driven, a decision made by looking at the data is more powerful than intuition. Okay. All right, now the last thing in this topic is the data analytics life cycle, and this can be explained by this simple figure here. Okay, so how does the cycle start with? Well, it starts with discovery, and then it follows all these steps until it gets to optionalize. Okay, operationalize. So discovery is like the beginning, where somebody realizes that this can be done or this can be sold. There is you can say a direction in which you have to move. Somebody discovered it. Who discovered it? Maybe it's coming from the user. Maybe you had an interest. You searched the market. You did some market analysis. There could be many ways in which discovery can happen. And then the slides you have some simple ways from the book. But in practice, it could be many ways through which the discovery can happen. Okay, the discovery of what? Of the task, of the thing that you need to do. For example, somebody says, okay, let us build an app that does this, and it requires data analysis, okay, data science. So that discovery is what is here. Okay, how did that person come up with the discovery? Maybe he had experience, maybe he was aware of the market. There could be many ways. Okay. Then based on that discovery, now you have the next phase is the data preparation phase. Here is the place where you're going to see, do we have the data or can we get the data? If yes, from where? How much will it cost? Is it for free? So you're going to see, can we get the data or from where you can get the data? And when the data, let's say, is available, you purchased it or it was collected, then how to clean the data? What are the things that you need to clean in the data? How will you prepare the data? Okay, that's the data preparation step. Once the data preparation is done, once you know what data you have, then you think about which model to pick. Now, at the beginning of this discussing the syllabus, we said we have, for example, regression, classification, clustering. These are the three big areas, but this is not everything, of course. And even in these three big areas, you have so many small areas inside. Okay, so what is the right model that you have based on your data? That's where you do the planning for the model, and that's the step number 3. And then you do some model building. Here you decided, okay, I'm going to go with regression model 1 and regression model 2. That was your plan here. But now in this part, you are going to actually build the model. When you build the model, you build the model on a you can say sample data on a sample platform. Why? Because you don't want to, because remember, all these are experiments, and here it's an experimental phase. So you don't want to change, manipulate the real data, or that will spoil the data, and you don't want to take any decision then and there. So it's like a pilot study. It's like experimental study. So you build a data modeling sandbox where it's like a temporary experimental phase where you build the models and see how different models are behaving on your test data. And if you find reasonable good results, then what you can do, you can communicate the results to your let's say team leader or manager or the guy who is actually interested in this study. And once you communicate the results, if it is accepted, then it will move to the final phase, which is operationalize. This is where you materialize what you have done here. Okay, here you did something on a small scale, maybe on your laptop you did small model with the sample data to see how things can be done. And if it is approved, you can actually build on a big system, maybe mainframe, maybe something on a bigger scale, and see how it is, and implement it. And that's the operationalize phase. And that's it, that's the end. And then the cycle goes, and based on the product, maybe you'll have some changes in the market, and then you might have a new discovery, and then you taking that new discovery, you the cycle, and the cycle goes on and on. Okay, so that is the data analytics life cycle. Okay. So I gave you quick information of these topics, and actually that's all what we have in this first topic. It just again to create motivation and to just to highlight how the data science is going to be a good area. And even now it is very hot area, but it will be something very common knowledge in couple of years. Okay, and I hope with this overview I give you some encouragement to look into this area. And when we start things from the next chapter, we will have some motivation, and hopefully maybe if we have time, we can look at some data from this Kaggle website and see how we can analyze it. And maybe after the course you guys can participate in a team and might win even those competitions. Okay, all right, so I'll stop here. We have 1 more minute, but now we'll stop here. And from the next class we will have the actual the next topic, which is the review of Python. So we'll have class almost every day except on Thursday. So if you are weak in Python, please have some readings, watch some videos. These days you find lots of videos, and Python is something that is so popular that you'll find too many videos available on YouTube or any other online educational domain. And have a quick review of your Python, so that when you come to the next class, of course I'm going to start from I'm not going to start completely from scratch. I'm going to start from where you left in ICS 104, somewhere there. Okay, so if you guys took ICS 104 1 or 2 semesters back, please revise it, have refresh the topic, and in the next class we should all be in the same phase, or at least should be able to understand. Okay, all right, so let us stop here. Do you guys have any questions, any comments? Any comments?
No, thank you, Doctor.
Thank you, Doctor.
Okay. Okay, guys. So if you have no further questions, let us stop here. And please, I saw some of you came late today. Of course, at the beginning of class, I will give some review, but please don't come too much late. 5 minutes is fine, but beyond that, it will be, you will miss some contents. Okay.